All right, so this one says consider the first four terms of an arithmetic sequence. Now, one thing I want you, we're going to talk about arithmetic and geometric. So right off the bat, I want you guys to recognize that arithmetic has a common difference. And that common difference is we're going to add or subtract the same number. Okay. And it says below. So before we even jump into that, I'm adding 6 to go from 7 to 13. From 13 to 9, I'm adding 6. From 19 to 25, I'm adding 6. So let's label this. I want to talk to you about recursive and explicit notation. Recursive notation is like I'm going to add to the previous number. So recursive notation, a recursive function, the values are like this. So f of 1 is the first term. So this is the term, and this is the value, 7. So the first term is 7. F of 2 in this sequence is 13. Now, it's different than an explicit function, because the explicit function is a function like, what is the equation? When I plug in 2, how do I get 13? When I plug in 3, how do I get the next term, 19? All right. So then f of 3 is equal to 19. F of 4 is equal to 25. Now, this is recursive. And so what they want to know is, what are we doing? So one thing that you can say, and we're going to go through a lot of example problems. The way that recursive notation works is I have my first term, f of 1 is equal to 7. I'm getting that from here and also from up here, right? Up here. How do I get the next term? Right? How do I get the next term? Well, f of n minus 1, right? And this term is usually referred to as n, right? So it's like f of n is equal to f of n, right? So my recursive notation, in fact, wait, let me draw that the other way around. So my recursive function would be f of n is equal to f of n minus 1. So this is the current term. This is the previous term plus 6. So up here, you're just going to put plus 6. And what this is saying is I just take the previous term and I add 6 to it to get the next term. So let's step through that. To get f of 2, I'm going to take f of 2 minus 1, and then I'm going to add 6 to it. Well, what is 2 minus 1? F of 1, and I'm going to add 6 to it. Well, what's f of 1? F of 1 is 7 plus 6, okay? So my second term then is 7 plus 6, which is 13. Hey, guess what? That's true. Now, if I were to continue on with this, if I wanted to know what f of 3 is is equal to f of n minus 1, which would be f of 2 plus 6. Well, what's f of 2? 13 plus 6, which is equal to 19. So f of 3 is, and then if I do that to find f of 4, I'll get 25. Okay, so that's recursive notation. Now, explicit notation is trying to find an actual formula, right? So this is like what you guys are accustomed to. What's my f of n? Well, my f of n is going to be equal to the common difference, right? Which is 6 times n, right? Because we're adding 6. But really, we're starting with a number. So the first term, so this is always going to be the common difference. This is going to be the common difference, and we'll go over this several times. It probably doesn't make sense now. And then we got to figure out, well, how does that work? So if I think about this, f of 1 equals 7. So to do the explicit function notation, I've got to figure out sort of what I add. In other words, if I do an explicit, I'm going to say f of 1 is equal to 6 times 1 plus 1. So I'm going to say 6n plus 1. So this is the function. This is the explicit function, right? This is like an equation that you guys are used to. Some textbooks would say implicit for this and explicit for that, and we'll talk. Well, implicit and explicit means different things, so I'm not going to get into that now. Just know that this is the explicit, right? So then, if I want to figure out, so what we would put here is our common difference 6, and then plus 1 here. So let's test this. What's f of 2? Well, that would be 6 times 2, right? Plus 1. 6 times 2 is 12, plus 1, right? So the second term then would be 13. And so that works. But they want to know what's f of 10. So because I've got the correct explicit, I can figure out any term in the sequence by just plugging it in. So f of 10 is equal to 6 times 10 plus 1. Well, that's just 61. So what that is saying is that my 10th term will have a value of 61. So up here, we would just say that value is equal to 61.